Welcome, Magnus.
Yes, thank you. Can you hear me? Yes? Yeah. I'm Magnus Selje. I am one of those volunteers working with Wikidata. And I work with Wikidata mostly, not so much with Wikipedia because I don't trust it. So my approach with Wikidata is a little bit religious. And I was working on a bank doing Scrum Master and so on. And then I said, this is enough for me. Now I should do something else. I didn't think about Wikidata, but now I am been doing it for 1 or 2 years, or more, 3 years maybe. So I will do some introduction to the Wikidata project, what's happening, because I think it's happening a lot of interesting things, and also my thoughts of things I have done. Because the interesting thing is that I'm coming then from being a Scrum Master on a bank where we have $100 million in New York that can't be delivered, action. And then you know you are on the stage. But then with Wikidata, you are no one. You have to create trust with people in an odd way, for me, saying I normally run around and shout. So Wikidata is to data what Wikipedia is to text. Maybe everyone knows Wikidata. Has everyone been working with it or no? So it's completely free. All the data in Wikidata is CC0. So it's just, you can use it for commercial use or whatever you want. Anybody can contribute. Sounds great. Sounds dangerous. And how it grows, you never know. So there is a problem with quality, as you have with Wikipedia, but also you have a lot of possibilities, I think. The cool thing with Wikidata is based on the same technology as Wikipedia is, and Wikipedia has, I think, 10, 15 years been alive, and they have learned how to track versions, roll back, and so on, because they have, as everyone can add, not everyone is doing it with good intentions. So they have a good engine at the bottom where you can correct things, find things, and so on. And last week, they started also using machine learning to find patterns which are less good. So I was spending some hours training it, which was a nightmare, because then you understand how big Wikidata is. You get some question, is this a good edit or not? And then it's on Hindi. So then you get respect how big it is. So the ambition and mission with Wikipedia and Wikidata is to have all the world knowledge. And I was sitting earlier last year together with 2 girls from Ghana, and their problem was that internet was expensive. So if they succeed giving knowledge to everyone, I think it's magic. So the project is magic, and a lot of people like it, and some hate it. At the bottom now with Wikidata, we also have a Sparkle engine, and you can define your own properties. You have to request properties, and then it's approved, and so on. So the structure is Wikipedia, you know. Everyone can today download their own MediaWiki and create their own Wikipedia. So it's the same. Where did we have this high-tech tool? It's gone. Oh, there, thanks. Cursor stick. Yeah. So this is the Wikipedia we know. 300 languages, I think it's now. And then you have an engine MediaWiki, which you can download and install your own wiki. So now with Wikidata, it's connected, I will show you, to Wikipedia. You get something called Wikibase. Lesson learned the last year is we shouldn't have everything, as some earlier speaker said, we shouldn't have everything in Wikidata. We can't have all the books, we can't have, etc., etc. So then they have done a version of Wikidata called Wikibase. And the goal 2009, this year, is to make this easier to use. And the project is driven by people in Berlin, and they are extremely good delivering. And you can follow and track what they do on Fabricator, a workboard So you can subscribe, comment, and so on. Also under development is this schema. So you have ShapeX, which is also interesting. It's a way to get better quality. So this is the roadmap for 2000. ShapeX support, I've seen it in test now. I work a lot with culture data, and the problem with culture data is not rocket science people sitting there. So they have problem having their own database, own Sparkle, and so on. So they give away the data, and they have no life cycle thought. So they give away, and then they are happy. So what we start, not me, but the Wikidata project, we start also looking into have signed statements. So if you get data from someone who is trusted, you should be able to see if this data has been changed or not. What is much better is that a new ecosystem is built. And that means that you can set up your own wiki base, which I spoke about earlier. And to make the entrance level easier, put in production federation ontology reuse. So that means that instead of starting from scratch, you can say, this is my site, but I will reuse the objects in Wikidata. So I will show at the end that you will have all the pictures in Wikipedia will from yesterday be a Wikidata installation. So then you can say, this picture depicts the same object we have over in Wikidata. And that open up. And in the next version, you will have relative position in picture, which is even cooler. So then you can say that this is person the same as that object and so on. So then you can using Sparkle to retrieve all the characteristics of people and then this SPL. So I can search for all people in SPL who are but I'm religious. It's an enabler for linked data that you can from a two-dimensional picture move over to an object and get all the stuff. We are doing the same, OpenStreetMap is doing the same. They have their square for a building and so on, and they have one property called Wikidata. So then you can say this square is the same as the unique number Q, which is an object. And then you get, it's a building from the 1700 architecture and so on. So I think that's the magic of it, the reason why I'm religious. Other things that's coming is to make it more user-friendly. I installed this Wikibase in November. Then it's a Docker installation, and I'm too old for moving parameters back and forth, I think. I did it when I was younger. I think that is the interesting thing. So, Wikipedia, you have a lot of text. In the best of worlds, you also have sources. What's coming now is that the English Wikipedia, I think, start looking into asking machine learning to find what statement should have a source. The good thing with Wikipedia is that no one trusts it. So they go in there and say, we are not the best. We have to prove that we are true. So you can't trust this if you don't have a good source. And that is, I think, a good mentality. We have another big linked data project from the Swedish National Library do. They have the other approach. We are a Swedish National Library. Trust us. And I think it doesn't work in a linked data world when you have all the sources and so on. You need to get trust. So what you see here is normal Wikitext. What's coming here, it can be from Wikidata. So here we have in Swedish, edit Wikidata. So all those sources here is coming from the National Archive, for example. It's a very good source called SBL. I will speak about it. And then you have the church book. In Sweden, all the church books are free. So here you have a primary source, a secondary source, and so on and so on. And if you jump down to this Wikidata, oops, it looks like this. A bad user interface, but it's there. You have place of birth, you have an object where he is born. It's a Swedish church parish, which has location and so on. But then you also have references. In this case, it's 4 references. It's a def index. Is this good source, SBL, which I will speak more about, from the National Archive. This is also from the National Archive. So it's the census 1900, and this is also from the National Archive. It's the birth record. And the funny thing is, this is the place where they meet. They don't meet over at the National Archives. They meet at our place. and maybe Wikidata can add value. Should I understand this? Whoops. Here. And so if we go down to JSON, we have this data down here. We have this SBL, but we also have how the birth dates looks. So I have a calendar model here. So that means that you can have Julian calendar, you can have Gregorian calendar, you can also say it's after, before. So they have a lot of things. Not everything is seen in the user interface, but this calendar model is good, we will learn when we look into the Nobel Prize winners, because the Nobel Prize winners is also in this database, and I have done some connections with them. And the problem I see with the Nobel Prize is that we are giving it not just to Swedish people, and then we get a problem when the people are born in another calendar format. But that's my point of view. Yeah. So what I have looked into is I'm coming from have something like that. We start doing Agile, and now I'm in the Wikidata world where you know no one, you don't meet them, you don't have meeting. It's crazy. And then you should start working together with other people. And that's the tough thing is you're coming saying, I would like to do Wikidata, linked data, and no one cares. So that's we have a problem. We need to find those interesting applications that make people aware how good it is. And I think it's sad when we look on this archive stuff because it adds so much value, is my feeling. I will show some example of that. So this P3217 SBL National Archive, was it a good or bad meeting with Wikidata? SBL is, I asked to add it, and then I learned later, and I think some people here in the room are more skilled than me to say they are the best. Started in 1918, so it's high quality. Every person who is in the university and do something and don't check them has to go home and do their work again. So it's extremely good source. We have some communication with them. It's rather easy, rather simple, and we get a very good answer 90% of the times. You understand they are domain experts. But are they a good member in the linked open data landscape? And my feeling could be better. They don't have a version management. So if we say something is wrong, which we nearly never do, we can't track it. So we can't see what changes they have. We can't, when we speak to them, we don't get a unique number. You need to have, as I'm used as a Scrum Master with banks, then you know this problem with $100 million in New York, that's 14455. But here you send them email and you don't know if you get an answer. So if you look into the Wikidata people, they are much more structured. They have this open backlog, prioritized backlog. And I think that's pattern we need to have if we are going to speak about linked open data, because you have to discuss the domain, I think, much, much more than we do today. But the cool thing with Wikidata is it's open, so everyone can add whatever they want. But you get discussions. And what I also miss in from the SBL is fair data. You can't get the research they have done or the sources and so on in a good way. And it's not machine readable in a good way. So the question is, can we trust Wikidata if the data is the same as SBL? I think that's an interesting. They are the best in Sweden doing this kind of research, but can Wikidata trust them even if we are the same? The problem with Wikipedia and Wikidata is if we scale when we scale, add those 7,500 people to Wikidata, we have articles in Swedish for all those. 4,000 of them are people who are added. We have articles in English, but we also have articles in 300 more languages, 204 more languages. So the question is, how should someone reading in Hindi understand that this source can we trust? And I think that's a problem we get when we scale it like Wikidata, that we need to define how good a source is. I have seen with the Nobel Prize that people evaluate prizes and say this is better than that or not. Maybe that is the way. I have no answer to this, but it's a problem that when Wikidata with its scale start using it, because most Swedish people don't know what this SBL is. So I see that as a problem, a linked data problem. And maybe it's a problem that the National Archive should tell the world how good they are. I don't think they will. They are not that kind of people. Another thing we did was Nobel Prize winners. Small data set. Has Sparkle endpoints, so you get so happy. Excellent candidate for federation. So what I did was that I asked, could we have this as an endpoint? And we could. So then I do the Wikidata query here. I send it over to the Nobel Prize endpoint and get back an answer. Excellent. It's like the school book. You could do odd things like this. What Nobel Prize winner has a Twitter account? and Bob Dylan had one, and it's not everyone who has one. So, and you can also ask what Nobel Prize winners has a place on March that are named after them and so on. Wikidata has too much odd information, but it's funny. So this is excellent. So what I also did was that I used something called Listeria, setting up that every night we have a compare Wikidata with the Nobel Prize. And then my question in the beginning was, can we trust Wikidata? Is it time or? Yeah. This will be the end one. And then what we see is a lot of differences. So we have Isaac Bashevis Singer, which Wikidata says 1902, Nobel Prize says 1904, Nobel Prize has no sources. What we see on the comment in English Wikipedia, we can see that he was cheating because he did the military service, didn't want to do the military service and so on. But I don't know if you can trust it. I should do the last one. We skipped this one. Sorry, I'm speaking too much. It's about this federation ontology reuse. So what's happening is that if you start using linked data, you have a book like this, you can say this is a book about the church, but it's also a book about all the kings and so on that have grace in this church. The problem if you start from scratch, it takes a lot of time to define all the objects. So with the new version, which is shown here on Wikibase, is that on a picture of this person, you can say that this person depicts Shakespeare. And what you will see in the next version is, we have done a test now on Wikidata, but this will be moved to Wikicom, is that you can say that all those parts are a picture of persons. And now I said this is the Russian version. So I can get, because we have linked data, we have labels in the best case with 300 languages, you can in an easy way change language to Chinese and so on. So I think that's your example with the paintings and so on. You can just steal the Wikidata thing and then you can deliver it 10 more languages. Yeah, I mean, you can steal it. I'll stop here.
Okay, thanks a lot, Magnus. Very interesting. Do we have any questions? Yes, we have a question over there, Eric. Magnus, there is a question for you.
Hi. Magnus, thank you very much for your presentation. I have seen that you are working on basic SHAX support.
Yes. I'm not, but they are.
Yeah, they are. Do you have any idea if shackle support has been discussed? Because I mean, SHAX is just returning it conforms or it doesn't conform, but it doesn't tell me what is wrong.
I think they will have a validator and so on.
No. I'm talking about SHAX versus shackle. Those are two.
I'm not so updated. Sorry.
Sets.
I write the SHAX validator, and it returns a lot of information about what conforms and doesn't conform. If all you're getting is conforms and not conforms, you're not getting the full stream. So,
okay,
we need to talk about that.
Okay.
So it's in a test site, and it moved to production, I think.
Thanks a lot for this. Any more questions? Okay, let's have one more then.
So,
Magnus, you're not done yet.
Sorry. Good for you. This is Fredrik here. So, just one question, because I mean, we all know that Google acquired knowledge base. In DBpedia and Wikidata and Google's stuff they're doing with their knowledge graph, because that's kind of that's where you see the use in the Google knowledge graph, because they're actually using the Wikidata stuff.
I'm not in the core team and so on, but what I see, I added a place on Skansen in Stockholm was in Google, and Google had positioned it. So they are listening, using it all the time. DBpedia, I think it's an early version. I don't know the political relation between Wikidata and DBpedia and so on, I think. But Google is always there, is my feeling.
Thanks a lot, Magnus. We will continue with our last speaker before we go into the panel session. So welcome Ketil Kjærsmo from Inwrapped. Ketil will talk about solid pod reshaping the web as we know it. And I see you have already starting to reshaping the text here from what I got from you. So welcome. Go ahead, please.
Thank you very much. I work in a company called Inwrapped, and we are trying to build something around the Solid project. So Inwrapped is an American startup based in Boston, and it's the CEO is John Bruce, and the CTO is Tim Berners-Lee. The latter, I think you know. Create a commercially sustainable ecosystem around Solid. And then there's me. The IT industry. I worked for different companies, amongst them Opera Software, where I worked on the social networking website. Then I went back to academia and did a PhD. Which I finished 2 years ago. And I've been in sort of around the semantic web community since 1998. And I would also mention Ruben Verbon, who's a professor in Ghent, in Belgium. And he's a friend of mine and a partner in crime, and he's also written quite a few of these slides. So our sort of analysis of the situation is that business models that focus on data harvesting and persuasion architectures, which are quite prevalent today, has many bad effects, like stagnating innovation, alienation among citizens, and the situation that a few winners takes all. And it is also causing a very general exploitative environment. So we really need a new social contract. So, the Solid ecosystem. Solid is a decentralized web technology, much like how the web was originally intended. It has a lot of semantic web in it, and the the most important aspect technically around Solid is that it brings back choice by decoupling data and applications. We should see the consequences of this later. So, for example, it means like an application like, for example, Facebook doesn't encompass all your data. And you can also control how each piece of data is shared with whom and with what applications. And that enables what we call personal data control. Personal data control is probably the most important social aspects of Solid. But let's go back and remind ourselves that the web strives to be universal. The web really brought universality, as opposed to earlier technologies, as a central tenet, and thereby enables permissionless innovation. And anyone can use the web regardless of what kind of hardware they're using. For example, if they're using a desktop, phone, tablet, and so on, a watch, and so on, or what kind of software they're using across operating systems, browsers, applications, and so on. So the time before the web, it was quite hard to innovate. Like for example, when you had to choose what kind of hardware platform you would go to, or what kind of network technology you'd have to choose. So you don't depend on these things to innovate. You build for the web, and the standards provide interoperability where standards exist. I mean, when you go high variance things, then obviously we don't have the web standards to address all those problems. So Solid, this is the Solid logo, and Solid means social linked data. And what Solid gives you is that it gives everyone a pod. A pod is where you store and manage your data. You have some people are talking about it like personal online data store. I think that's too narrow. We have to think it in much broader terms than that, even though technically we're not there yet. It also gives everyone an identity on the web, a web ID. And a web ID is a URI for you as a person. It identifies you as a person that you can prove to others that you control for authentication. So it's also an authorization system that provides some fine-grained control. It's not very sophisticated at present, but it can be extended in many different directions. And also it takes advantage of different security mechanisms, so that you can most computations on Solid will happen on your device, not somebody else's server. So now this is the it's become kind of nice to have these things now. so this is the kind of thing that we are used to now, which is sort of your post about some kind of article that you read. So you're writing some text about some things, and you get a few likes, and then there are comments underneath. And in this case, this might be stored at some social networking site entirely. You submit your data, and it's suddenly beyond your control. In a Solid world, the author's name and last profile picture will be stored in the author's own pod. And a work-related opinion about the article, which is this one, might be stored in your company's pod. The discussed article might still be stored at the media, the original publisher's pod. And then there's a lot of likes and comments, which is stored at each individual commenter's pod. So this is kind of the way you start to see the effect of the decoupling of data and applications. But it goes further than that. So you can grant applications and people access to very specific parts of their their data. The current situation with centralized web applications is that, for example, Facebook owns your contact list, your pictures, your agenda. LinkedIn has possibly a different contact list. Porting between those two things, there's a silo here. There is very bad interoperability. And then you have, for example, Doodle that has your agenda, and this isn't interoperable. It's quite a bad user experience, actually. In decentralized web applications, it's quite different, because your pictures will and your agenda and your contact list is stored in your personal pod. So you will have different applications working towards this. So this means that you get a much better area of interoperability, and you can choose different applications to access your data, and also others can use different applications that you do. For example, if you have a teenager who's sharing some photos, some of those photos might actually be shared with grandma, but grandma isn't using the same cool application as the teenager is using. They're using an application that is for grandma, but they're still allowed access to some of the teenager's photos. And you have a social feed that integrates all of this, and it's also integrated in a much bigger social environment. And the effect of this is that in the current situation, you have a single market for centralized apps. They are competing based on data ownership, but they are owning our data. And the problem with this is that an innovative competitor have to either try to slurp up as much data as they do, or they have to do something completely different. They can't add a certain feature because they can't get into this market. So when we separate app and data markets, you will have competition based on this, based on the services that you provide into the network. And also in the data market layer, you will have competition, for example, based on service quality. Some might give unlimited storage. Some may be focused on high-speed transfer, and you can actually choose where you want to store your data. You might have several of these providing services for you and paying for them. So the effects of this will be far-reaching. Like, for example, the example that we had earlier today, where you have like Uber owns no cars, Amazon has no books, and so on. So the effect of this, I hope, will be that you provide your car. You still have your car, but the applications that you can build around mobility will undermine that kind of business models. It's not a good idea to have companies that powerful. And so this unlocks permissionless innovation. It enables people to experiment with solutions to their problems. It counteracts this sort of technological elitism that people outside our sort of in-group are experiencing. Permissionless innovation has historically brought unprecedented creativity to the world, but it isn't really the whole solution to societal problems. My personal opinion is that society must seek to enable a certain social entrepreneurship, and that also academia has to be enabled to move much quicker than they are allowed to now, so that they can study the effects of this also in the humanities, and the social sciences can study the effects of the technology at an early stage. So permissionless innovation is enabled by personal data control. when people control their own data, they are more resistant to this persuasion architectures, where you have these examples of how Facebook is trying to persuade you to share all kinds of things, and it's really exploiting psychological effects to their own benefit, but not to ours. They are less dependent on data harvesting business models, and you're also more resistant to other forms of exploitation. They are freer to choose applications that suit them, and that's not just for utility, but it's also about what kind of applications matches your personal values. And it enables competition based on the value added and not the value of our data that they are holding. And since people are not anymore locked in, it's much easier to enter with innovations. So personal data control is really what unlocks permissionless innovation. It also enables smart cities, like we talked about today. The example of is that smart cities will require personal data, like things that my position of my car when it enters a pothole. That's something that's really actually personal. It identifies me. So smart cities will need to respect their users and their users' expectations for control. And if we have these if you allow to have these centralized architectures that gather up lots and lots of data, we are pretty much creating an unprecedented surveillance society, and that I think people will be rejecting. So, for example, you have this. This is Norway's largest magazine around cars. This is the front page from January 2017. Connected cars. Your car is spying on you. This is the message that people are getting now. So I think personal data control is really the key to unlock the potential of shared mobility, which I think is very important. So shared mobility is very important because it will cut traffic, and it also will cut emissions. Not only because people are sharing, but also because electrification of transportation can go much faster. But it's still important that city development must be democratically driven and not be in the situation where the data is controlled by some centralized organization, and therefore they know much more about how the city should be developed than democratically elected governments. And therefore people must have a certain personal data control. And we have to avoid this situation that we have now, where we have this winner-takes-all situation. So I'm daring now to show some turtle, because people have done that before us, and this is how our really simple access control is looking. So you have here a simple authorization to a certain access to a certain thing by a certain agent, and in this case that agent is me, and I have read, write and control permission, and control permission is the permission to change this. And I also have an authorization for an agent class of FOF agent, which means everyone, so everyone can read this card. So this is very simple, but it works. We have it right now. It works right now. And I think that this agent class construct can also be extended. So right now we're focusing very much on developer tools. So We have a prototype Solid server, and a rewrite of it is in progress. We have recently released a software development kit for front-end applications based on React. And we're also trying to make RDF much easier to work with, for example, the LD Flex system. Yeah, I'm jumping to the last slide here. I think that in societies like Norway, where I'm from, and Sweden, we have this rather good social cohesion and trust in governments and stuff like that. I think that government should think about very carefully about giving everyone Solid, because it enhances the public security. It allows people to truly exercise their rights. Like, for example, we have this right to data portability now, but if we take that data out, where do we put them? And how do we use them? That right is really worth nothing. Alternative. It helps free people from exploitative technology companies, and it enhances innovation, and it improves people's ability to participate in technological development, like the self-care that we just heard from Hannah. I think that's very important. And I think that is also that public services can also avoid these centralized architectures that are not scaling. It's also important that public services can be where the user is. I mean, in Norway we have lots of nice platforms, but it's not where I'm spending my days. So Solid interrupts technology. It is a common platform like the web itself. And I think that though this is quite simple, I hope it is, and I think it is, were the technical contribution towards a better social contract. Thank you.
Thanks a lot, Ketil. Do we have one short question? Eric, you can choose. Pick and choose.
Thanks. So who will manage the pod? Is it a company or government?
It can be you. So I have my pod in my basement. Anybody can just download this and then put it on a box.
But somebody has to maintain the infrastructure, right? The
Yeah.
pod infrastructure. So it can't be just me.
So there will be a lot of different options, right? It's people like me will probably do everything themselves. Others will go to a commercial company and get like we call them a pod provider and get this as a product. Others again will have the government will. Others again might get it from their health service. It's sort of completely open who will give you a pod, and you're probably going to have many of them.
So basically my question is that if a commercial company comes into the picture, then it will be the same case when Facebook comes.
Yes, it might be, but it's sort of it's architecture for being decentralized. So it's unlikely to have the same kind of effect. But I really see the point that you might be getting into the situation where you're being asked to just move your data from one megacorp to another, and but we were conscious about that not happening.
Yeah, that's what. So it's the interoperability. The problem is not the technical interoperability between Facebook and LinkedIn. It's a business monopoly. That's what.
Yeah, sure.
Thanks a lot, Ketil. Really nice. And now we're getting into our last part, and that's the panel discussion. So I would like to have the following people up on stage: Professor Harald Solbrig, Professor Harald Sack. Then we have Dr. Ratnesh Saha, and then Ketil, who's already here. That one is coming, yes. And then 1, 2, 3, 4.
All right.
Yes. 2 seconds. So Fredrik will actually handle the panel discussion, and we will try to switch with the microphone like that. So I give you this one, and then you could go ahead.
Yeah, and the question is do we have yet another microphone if there's questions from the floor as well to the panelists?
We're going to switch around.
All right. All right. So I'm very pleased to have all of you on stage. I have set up a couple of questions. So the one we are continuously referring to is like competing standards and the interoperability chasm of closing in. You were referring to the variety of data. You have been referring to the continuous development from HL7, 1, 2, 3, 4, 5, and going forever. And we have your last talk about we want to decouple to get away from the closed-in model from some of the large vendors who are running really big businesses. So the question is, how will standards interplay with interoperability with knowledge graphs and AI, basically? I mean, do we see what's the kind of future trend? And I think you reflected a little bit about that in your last, section, Harald. So anybody?
Okay, so first question from my side, what do you mean by AI?
Okay, very wide definition, but the use of machine learning mechanisms as you presented, the narrow perspective as we see it now, not maybe how and the future to be when we will be extinct by evil AI. So,
I mean, we have already seen lots of standardization efforts for knowledge graphs, so the entire semantic web technology stack that is there is already some kind of standardization, which is of course crucial for any kind of interoperability. Things like that, as far or concerning my knowledge, are not really existing for machine learning. So the only thing to exchange there is everybody is implementing this stuff on the same kind of libraries, which is PyTorch, TensorFlow, and all of the stuff. But what I think would be interesting if we would have description standards for machine learning models, so that, for example, autonomous agents would be able to select, to use, exploit, integrate, aggregate, these kind of models for their purposes. So this, I think, would be something interesting to see.
I do have to contest your HL7 way we would look at it is the porridge was too cold and too hot, and we've hopefully got it right this go around. I don't anticipate another standard this one actually takes. Web directly, not so sure. But one of the things that's been missing from deep learning, big data, and knowledge graphs is good quality healthcare statistical data, the raw data to go in. We have local studies, but the data that's in the local studies is very hard to integrate. And I think the next steps, especially with some of the work being done by it's the evidence-based medicine on fire community and others, is going to make the sorts of large data sets that used to be the property of the Mayo Clinic and Johns Hopkins and Kaiser Permanente available to whomever wants to use them to discover their linkage to other areas in aggregated and de-identified forms.
Yeah, I'll support Harold in a way that I see as a two-part. One is the technology suite, and other is the conceptual thinking between knowledge graph and AI. By technology suite, I mean that W3C has done a lot of work, but then HL7 has done a lot of work. So interoperability is at very different layers. So it's not just one layer. Data, message, when we see that W3C and HL7 is joining hand, an example is fire. So this is the good news. This was not happening before. At least I haven't seen importance from V3 to fire. So that was when W3C and HL7 coming together. So that's the technology suite. But from the conceptual thinking, machine learning and the semantic web and linked data, the AI. So one semantic web and linked data and knowledge graph is the top-down conceptual thinking. So some expert sat down, some domain expert, they defined the classification and association, a class, subclass relationship, properties between two. So we saw that there has been a lot of challenges in that. I can agree, you can agree. So lot of effort has been invested into consensus building in that top-down approach. But then we saw machine learning approach, which is the bottom. So your data, my data, all data, and then exactly what you are doing again, you're again from the bottom up, you are trying to find the classification as an association between given entities. The cool thing for me, or what I hope that within a couple of years, what I want to see is the melting point between bottom up. So I think that there is a melting point happening from the technology front, but this is yet to be seen.
A very good point. And as you said, I mean, we are reaching linguistic uncertainty because the translation of meaning between different, technical repositories and human beings doing the record keeping, as Magnus was just referring to, how we actually trust the meaning of the intent to why they do the organizing in the first place. So I see, as you said, the top-down approach is that, we can apply some standardized consensus thinking, like, what is referral to the, together with the spatial data community, where they actually found some common grounds on, defining what is a spatial thing to some extent, as well, and bridging between the different standardization communities. Thank you. So I'm actually going to go back to you because you were the last one to speak here, and now it goes back to the the privacy of your data. And I think one of the questions were referring to, yes, I do really like the things, the whole idea behind the web, being open and transparent and decentralized, which is the whole why we do have the internet. And the question is, for one thing for me is that we have the solid movement that's going on now, and Lee, the founder of the web, he has grand visions, but we have, for instance, other mega billionaires who have other visions, saying, I am Amazon and I own all the computing power we can see. I will not mention names, but you can imagine what.
So I think importantly, it's more than my data. It's about us. I think that's the most important sort of vision that we have, because I'm not an island. I don't really operate just alone. But on the other hand, the problem is that when we're talking about big data, it's when you don't have a say. So it's not this. There are perhaps two things that we kind of need to avoid talking about. Is what we call and that is not sharing. It's sharing. It's bringing data into value chains that are important. But I still have to have some control. What she showed was that her data was much bigger than the healthcare data. And I think that when she's asked to share her data and perhaps get that into the ecosystem, then that will provide value for a lot of people. It goes really right into
another aspect of Solid that you need to be able to say what you've got information that I want. We can't eat. That's one of the places that, to the best of my knowledge, although oddly enough, Eric Prumo says he can't talk about it. There are certainly rumors that the FHIR data model is being used inside Solid as a way of identifying and tagging certain types of data. So.
So since we've been, please, Hannah.
Instead of someone telling me what I'm thinking, I would like to say it myself. I mean, when we are sharing data, we really have to see not only what value we add to what we are sharing to, but also what value it adds for us. And I think that's important when we are looking into society aspects and privacies. So if we can gain things from sharing our data, that would enhance the possibility that people are sharing.
Very good statement. So, since we've been talking quite a lot about healthcare, so I just had a couple of questions about that. Healthcare and life sciences and the future of precision medicine. We didn't go into that detail about precision medicine, but since that's where you're heading in terms of the pharma, actually wanting to dive into these, large data sets and to be also, doing genomics and everything else. So,
like, as I said, like, out of 16, 17 years, 5, 6 years I worked for health records, 5, 6 years clinical trials, 5, 6 years genomics. When I was working initially, without having an idea that if a clinical record is captured, some sort of consent form is there, and if some description is there about what kind of genetic detail of the patient is, we never thought that one day this will be connected to some omics data set. So the point is that exactly this is the right time. What we see is that all these three spaces, clinical, omics, and the technology is coming together. This is driving the force, because even in 2005-6, there has been a lot of discussion was happening that how to combine them, but there was no technology support to actually do that. It was conceptually in our mind that, and even the precision medicine is now, but even classification, even blood group classification is coming from 1950s. That is also precision medicine. And those classification were to stratify certain patient into certain groups. So that motivation is from the very beginning, from the biological thinking, that someday this singularity will come together. This will come. What is important for now is that technology is there to support that conceptual thinking. It was not before. So we have very good hope for that.
Perfect. So I was, talking yesterday together with Harold and some of the others here, and one of the questions I had in my mind is that, well, how do you actually get things moving? And you were referring to that, how you build a strong community, as you have done in HL7, but the strong community, well, not all of us are linked data nerds, obviously, and maybe sometimes we need to explain what is RDF and all these statements we've been raising. But how do you bridge the different communities that actually put together the things? One of the things we were talking about yesterday was that, well, JSON LD is a simplification way of getting simple web developers to understand, well, there's a good thing to just have some micro format saying what is it that I'm trying to say on the web. But what's your thought about that? How actually get tractions between different disciplines, both experts within domains, but also different developer domains?
Well, there's two aspects. One thing that I thought was very telling about the Volvo presentation this morning, and you use the word linked data. There's linked open data, and the O part is a key factor. I've seen PowerPointware for years about the visions of linked open data, when the government gets this particular environmental data out and when clinical data with a bunch of whens connected with it. Something has changed, and I'm not sure what it is, but the slide you getting all that stuff, I've seen this in real life. The translator community has enough openly available data thanks to, well, Wikidata plays a part in it, open ontologies. For some reason, stuff is just becoming available, and that's very exciting to see happening. I don't remember there was the other part of the question that jet lag has caused it to fall out of my brain here.
Well, the main question is how we bridge between the disciplines actually as you mentioned, the community building. Meaning that you bring, you are clinicians and everybody else, talking about the standards. Right. If I start to talk about standards, ontologies and stuff in another room, most people will fall asleep. And I mentioned the word taxonomy. Yeah, and then you have, problems, keeping attention.
So there is a big issue. Semantics is on the forefront now. Everywhere I go, all of a sudden, folks have decided, boy, what we need is central terminology services, ontology services. We need all these naming things available. I think that's a huge hurdle. I don't think we have a good answer to useful ontology services. We know what they look like, but it does lead to the third part of your mention of the JSON LD. RDF and Sparkle, David Booth has some great posts on that if you look out on the web for it. They're not widely consumable. You have to spend a lot of time, and you have to have a kind of a twisted mindset, actually, if you want to be honest, to really get into using RDF and Sparkle in Anger. And we need some way of transforming, and the everyday developer can quickly grasp and start using it. And I think the JSON LD community, at least their hearts, is in the right place. Their focus is not on making JSON more useful. Their focus is on making RDF more useful. But I think we need more thought on that. We need more ways to get from the universe of semantics into local contexts that are easily used and meaningful to people.
Yeah, so I remember the time that when you talk to software developers, then don't mention the R word, because otherwise the R word means RDF, because otherwise they are scared off immediately. But what I am experiencing in the last years is that not really the software developers, but from many other communities. So we are working a lot together with library peoples, archives, and people from the cultural heritage domain, so museums and stuff like that. And they all want to do linked data, and they have people who understand how this is working. And sometimes I think if you try to learn RDF via JSON LD, this is much more difficult. So this is really the hard way. If I imagine I would have to learn it in JSON LD, then I can read a few lines, but JSON LD, this is much too much to read.
I really think it's up to openness and being humble to other people's knowledge. And I think that this We Are Not Waiting movement is a great example of that, because their diabetes patients and mainly parents have developed really cool algorithms and just do it. They just ran the algorithms on their child without no more than their own knowledge that this will work, because this is what I do in my daily life anyway. So when people go together and take their own private data and develop things, we will now have many hours of data where it has been used, those open algorithms. So it's a good way of seeing if it's safe or not.
And I can just refer to my own teenagers, because I've been not working as long as you guys, some of you, but when I started off with C++, there were the fellow from Denmark who invented the language, and I had to hack the Unix server to get access to internet, because we were at a closed setting at a car manufacturer company here. This is way forgotten, so I hope there are no security manager here. And then I hacked so I could actually connect with him and ask him what kind of parameters to use in the construct of the language. Whereas now the kids have the toolbox just in front of them. They can pick and choose. They can start, tinker around and develop things much faster than we could before. Is it anybody here in the audience who have a kind of a complementary questions to the set? Yeah, Mark, please.
Yeah, to follow up on that, and it's I'm really happy to be here, and I've learned a whole lot more than than I've conveyed. But we have an interest for a long time in knowledge representation. We have set theoretical knowledge representation, which is OWL. And that's good for defining things. All instances of X are also instances of Y, is what it boils down to. And we have a representation that's the loosey-goosey, well, it's designed for thesaurus work. Come on, SCOS, yeah, drawing a blank on it there. Where it's just broader than, narrower than, and somehow related to. There's got to be something in the middle. I think things have been done in the middle with common logic and other places. But when it comes to knowledge graphs, we really need to be able to more formally state things like pneumonia can be a cause of or pneumococcus can be a cause of pneumonia, or that there's a strong correlation between the use of a particular drug and a particular symptom. And I may not be working in the right space, but I haven't found the way to do that yet, aside from just colored lines.
As you said, like more and more can be done on ontologies, but one of the blockage is that ontology. So my UML diagram is also an ontology. OWL is also an ontology. XML schema is also an ontology. Classification is there. The point is that how much we can compute in a reasonable time. So there is a computational complexity. So we know that ontologies in all, they are within the first order logics. So you can compute certain fragment of it. But the moment you go second order and higher, so I like to express very expressive things, which will look good in the diagram, but when it goes to machine, when it goes to second order logic and higher, then you cannot imagine that your answer will be given in few seconds or a few minutes. Maybe you have to wait for maybe next Christmas. Because it's gone computation, computing. So that's the problem. So that's the barrier. The problem is not the expressivity. The problem is the computational in a reasonable time, which machine can handle. We don't have that capacity at the moment. And that's the problem ontologies is facing, which is coming from the knowledge graph community. But it's computational. So that's pretty much simple mathematics is there.
Yeah, this is also one of the problems that I was addressing. So if you try in a mechanical way solve questions that contain second order logical propositions, for example, or time-based stuff, and the point is all the procedures that we have, or the techniques, they are somehow something like brute force techniques. They require time. However, if you ask a question like that, a human is able to give you an answer very quickly. The problem is the human cannot be 100% sure that this is really correct. Now the question is, does the machine have to be 100% sure?
Yep. And that requires the whole computational infrastructure.
Yep.
I think one of you mentioned it is kind of the different hierarchical navigations from the top, having too simple and too narrow, ontology descriptors, or too deep and too descriptive that it doesn't make sense, and it can be able to level those different layers. And time, or Sebastian?
Actually, without a semantic data model in place, we have the issue that machines have no clue at all what the data are. So the possibilities of doing something with the data without a semantic layer are very, very limited. So it's not even a question, does the machine have to be as correct as the human, or, that's of course true. The discussion among librarians, for example, has been going on for decades if automated classification is doable at all, because the machines never reach 100%. But of course it is left out of the discussion that even the best experts can only reach 80% consistency with their own classification. Just let alone two librarians which don't agree, or librarians over time which tend to change their minds and all that stuff. But I think that it even starts much earlier.
You had one more question?
Yeah.
Okay, we have the last question here then.
I had a correction. And so, you said that true, OWL and other ontological languages, they may be too expressive to compute, but from the questions that I was asking today,
All is not too expressive. That's
I mean the full. Some people told me like, no, we don't use, from the questions I was asking presenters before, we don't use formal OWL ontologies, we use scarce taxonomies. And there is a very decidable OWL subset. Basically, you can do the first step of ontologies, which is fully decidable in good time. And I don't see many people taking it. So I don't think that we have already hit in production deployment a problem of, oh, we are expressing concepts too formally with so expressive semantics. I think we need to do the first step and actually just dip our toe into basic formal semantics, which most people with a college degree can learn in a week or less. And then I think we can continue to those problems. So I would advocate for getting a 101 in formal semantics.
Thank you. So, thank you everybody, and special thank you to the panel. Give them an applause. A very, very short wrap-up. I think we have had a great and very intense day. I have learned a lot. We have listened to many good speakers. Some of them are here, others are out here. Thanks a lot for all the good speech and also for all the good questions. So I think we can give ourselves a big applaud for this today. I will at least take some things with me from today, and that is that we know a lot of information. We can use it in many ways, but we are not even near to use the full potential of it. We need to actually accept all the different standards. We also need to accept that we have a big variety of data information. And then the sharing, which Hanna has brought up several times here and others as well, the open data, so we actually could go to the next step instead of this silo data we have today. And then the last thing that I will bring with me is, of course, the small story about the clever hands. I really like that one. Thank you. So, and also a big thank you before we leave here to AI Innovation of Sweden, that we were able to use these facilities. So everybody, that's what it is for today. Thank you, and I hope you enjoyed it.
Very good talk. Thank you very much. We'll talk about images. Reminds me of presentation.
Don't forget to return your white badge.
And he was showing where, for instance, the wheels of cars ended up working. So it doesn't matter Right. Yeah, but they classified it as a face.
So will you guys tomorrow here? Tomorrow here?
Thank you. And I can have that one too.